Okay, so back to number 9. So we had a 10 kilogram object going north, 6 meters per second. We had a 20 kilogram object moving south at 4 meters per second. They collide, and after the collision, the first one rebounds, goes 4 meters per second. So V1 final is going to be 4 meters per second, and if it's rebounding, then that's south because it was initially going north. And it wants you to calculate the velocity of the second one. Okay, so M1V1 initial plus M2V2 initial equals M1V1 final, M2V2 final. And we're looking for V2 final, so take this term over. M1V1 initial plus M2V2 initial minus M1V1 final, and then divide both sides by the M2 to get V2F alone. Okay, now fill your numbers in and be careful. Watch the positives and negatives because we have both north and south. Let's call north positive. So it'll be 10 kilograms times 6 meters per second plus 20 kilograms times negative 4 meters per second minus 10 kilograms times a negative 4 meters per second. And it's all, going to get divided by 20 kilograms. So the first term is positive 60 kilogram meters per second minus, and that's going to be 80 kilogram meters per second. And then a negative and a negative will be a plus 40 kilogram meters per second divided by 20 kilograms. So 100 minus 80 is 20. 20 over 20 should be 1. Is that what I really said the answer is? I did. V2F, just making sure the math in my head was right. Positive 1 meter per second, and positive was north in this direction, in this question. All right, that's number 9. Number 10. Number 10 says, a red ball of mass 2 kilograms is moving east. So 2 kgs, and V1 initial is 10 meters per second east. It collides with a blue ball that is also traveling east. Okay, but at a speed of 4 meters per second. So V2I is 4 meters per second east. And I don't tell you M2. Then it says, because of the collision, the blue ball speed, so V2F, increases to 7 meters per second east. And the red ball reverses direction, so V1F, and travels 5 meters per second, and it reverses, so that has to be west. And the first question wants to know the mass of the second ball, the blue ball. So M1V1 initial plus M2V2 initial is going to equal M1V1 final, M2V2 final. And this time we don't know M2, and they're in 2 spots, so we need to move them together. So bring this one over and bring this one over. So take all the terms with M2 to one side and all the terms without M2 to the other. Okay, so M1V1 initial minus M1V1 final will equal M2V2 final minus M2V2 initial. So just watch your negatives and which term is leading. And now over here you can factor your M2 out. So V2F minus V2I. And then you're going to divide by that bracket to get your M2 by itself. So divide by V2F minus V2I on both sides. Okay? So it cancels here. You're left with M2 by itself. M1 was 2 kilograms. V1 initial was 10 meters per second east, so let's call east positive, minus 2 kilograms. And V2F was 5 meters per second west, so it goes in as negative 5. On the bottom, V2F was 7 meters per second east, so it goes in as a positive, minus V2I, 4 meters per second, also east, so it goes in as a positive. So on the top, we have 20 kilogram meters per second minus a minus, so plus 10 kilogram meters per second over 7 minus 4, 3 kilograms. So 30 minus 3 should be 10 kilograms. I lost. The meters per second cancel each other out if you don't lose them. Okay, so part A is 10 kilograms. Part B says, what's the initial momentum of the red ball? So it's just looking for P1 initial, and that's equal to M1 V1 initial. It's not looking for change in, and the red ball was the 2 kilogram dude. So P1 initial is 2 kilograms times 10 meters per second. P1 initial, 20 kilogram meters per second. It was initially going east. That's part B. Part C says, what's the impulse on the red ball? So remember, J is equal to M delta V, or M times VF minus VI. So red ball, so 2 kilograms. Final was 5 meters per second west, so negative 5 meters per second, minus initial was 10 meters per second east, so positive 10. Minus 5 minus 10 is negative 15. Negative 15 times 2 is negative 30 kilogram meters per second, where this negative means west. It's why so the impulse being put on the red ball is in the opposite direction of its motion, which is why it ends up changing direction. Okay, so that was your last one, number 10. Where did it go?